Hello, this is Mr. Stansbury. I'm going to take you through the 19F assignment. Okay, so we start with number 1 here, 1A. Find the equation of the tangent to y equals f of x for f of x equaling this at x equals 0. So if you remember, in order to get the equation of a line, we really need three things. We need our x and our y, our tangent point, and we also need our slope. Okay, so we need these things, the point and the slope. So let's do this. Let's find the point first. So we know that the x-coordinate, they give us the x-coordinate. So for this here, our x is going to be 0. What we have to do is figure out what our y is. So to figure out what the y is, you can, whenever you want to figure out the y-coordinate of a point, just plug in the x, right? So we plug x into this, so we do 0 cubed plus 2 times 0, and that's going to be 0 plus 0 equals 0. So now we know the y-coordinate is 0, so we've got the x, we've got the x, we've got the y, and now we just got to figure out what the slope of that line is. To figure out the slope, that's always the derivative. Slope of the tangent, always the derivative, right? So we take x cubed plus 2x, and now we're going to do the derivative, so that's 3x, subtract 1 from the 3, and that's x squared, plus, and then we've got a 1 here, 1 times 2 is 2, subtract 1 from that, and then that x turns into just 1, so there's our derivative. So this will give us the equation, will give us the slope of the tangent at any point we want, and we know that our point, we know that x has to equal 0, so we're just going to plug 0 in for the x. So 3 times 0 squared plus 2 is going to give us 0 plus 2. So we now know that the slope is 2. Okay, so we have our x, we have our y, and we have our slope. Those are the three things we want. Now we just plug it into the point slope formula, which is y minus y1 equals m times x minus x1. Right, so y minus our y1 is 0 equals m, which is 2, times x minus x1, which is also 0. And we get y equals, distribute the 2 through, and that's 2x minus 0, so it's just 2x. Okay, back of the book is going to give you 2x minus y equals 0, but y equals 2x is just fine for the tangent. All right, okay. B. We can do the same thing. So we're going to find the y value. Okay, so we know that x is negative 2. We got to figure out what the y is. So to figure that out, we'll plug negative 2 into the original. So 2 times negative 2 squared plus 5 times negative 2 plus 3. Negative 2 squared is 4 times 2 is 8. 5 times negative 2 is negative 10. And then plus 3, that ends up giving us that the y value is 1. Okay, so what that really means is if you were to graph this equation, if you were to go negative 2 on the x, go up 1, and that's where the point is on this graph, and that's where that tangent is going to hit at. Okay, so we have our x, we have our y, we just need to figure out our slope. So to figure out the slope, that's the derivative. 2x squared plus 5x plus 3, and take the derivative of this. 2 times 2 is 4. Subtract 1, and that's x to the first. It's 5x to the first. 1 times 5 is 5. Subtract 1 from that, and the x's are gone. And remember, that's x to the 0. 0 times anything is going to give us 0, so the derivative of a constant is always 0. Okay, so this is there's our derivative function. Right, so that will tell us the slope at any point that we want. We want to know the slope of the tangent when x equals negative 2. So we're going to plug negative 2 in for the x. 4 times negative 2 plus 5, negative 8 plus 5. We now know that the slope is going to be negative 3. Okay, so we have our negative 3 for our slope. We have our x and our y. Now we're going to plug that into the point slope formula, which is y minus y1 equals m times x minus x1. Right, so y minus 1 equals m, which is negative 3, times x minus negative 2. So it'll be plus 2 there. So y minus 1 equals negative 3x. Negative 3 times 2 is minus 6. Add the 1 to both sides. And we get y equals negative 3x minus 5 for our derivative function. Our derivative function, but that's the equation of the tangent line to this function at x equals negative 2. That's our thing. So just really quick so you get an idea, 2x squared plus 5x plus 3. Let's just pretend it looks something like this. Okay. Let's say here is, I'm just making stuff up here. So let's say here's negative 2. Here's 1. So then now what we're doing is we're finding the equation of that line right there, which is this 3x minus 5. Again, that's just kind of a rough, I don't know what the graph actually looks like. It's going to be a parabola of some sort, but that's what we just found. We found the equation of that line right there. Okay? All right. Moving on to to the second parts of these. Okay, so now we've got find the equation. Oh, we did those already. Okay, here we go. So we got C and D. So same idea. Plug. Let's find the y coordinate because we need x, which is 2, and y, and our slope. So if we plug 2 in, so we get 2 plus 2 times, oops, there we go, 2 to the negative first. So there's where we plugged our 2's in. 2 to the negative first is the same thing as 1 over 2. So that's what this turns into. And so we still have the 2 here. So it's really just 2 plus 1 gives us 3. So that's that there. And then we got to find the slope of the tangent at 2. So we got to find the derivative first. So we have x plus 2x to the negative first. That's x to the first. 1 times 1 is 1. Subtract 1 from that, and the x's are gone. Negative 1 times 2 is negative 2. X to the, subtract 1 from that, and that's x to the negative second. This is the equation to find the slope of the tangent at any point we want. We want to figure out the slope of the tangent when x equals 2. So we're going to plug in 2 for that x. So our slope is going to be 1 minus 2 times 2 to the negative second. That's going to be, the 2 stays on top. 2 to the negative second is 2 squared on the bottom, which turns into 4. So that's going to be 1 minus a half. So our slope then is going to be 1/2. Okay, now we're going to take, so now we have our slope is 1/2 and our point is 2, 3. So now we'll plug that into y minus y1 equals m times x minus x1. Right, our point slope formula. So we got y minus 3 equals m, which is 1/2 of x minus 2. So y minus 3, distribute the 1/2 through, we got 1/2 x. 1/2 of negative 2 is negative 1. Add 3 to both sides, and we get y equals 1/2 x plus 2. Okay, that's going to be that's the equation of the tangent line to this function at x equals 2. Okay, so that's the instantaneous rate of change at that point there, at x equals 2 on that equation. All right, moving on to D. So we know our x is negative 1. Got to figure out our y and figure out our slope. So to figure out the y, plug negative 1 in. So we get negative 1 squared plus 4 all over negative 1. Right, so negative 1 squared is 1 plus 4 all over negative 1. That gives us 5 over negative 1, which is negative 5. So there's our y. And to find our slope, we got to do the derivative, right? So x squared over x plus 4 over x. Remember, this x is underneath both of those. So to simplify that, that just gives us x And this here, we're going to move the x to the top, so that is plus 4x to the negative first. Now take the derivative of this. Right, so that's x to the first. 1 times 1 is 1. Subtract 1 from that, and the x's are gone. That's not necessarily plus. Negative 1 times 4 is negative 4. And then we've got to subtract 1 from that, x to the negative second. This is our derivative function, which will tell us the slope at any point we want. We want to know what the slope is at negative 1. So our slope is going to be 1 minus 4 times negative 1 to the negative second. So that's 1 minus 4 over negative 1 squared, which we know that to just be 1 there. So it's really 1 minus 4 over 1. So that's going to give us negative 3 for our slope, right? Now we can take that negative 3 for our slope, plug this into the point slope formula, right? Y minus y1 equals m times x minus x1. Y minus negative 5 equals m, which is negative 3, times x minus negative 1. So those turn into positives. That's positive. Y plus 5 equals negative 3x minus 3. Subtract 5 from both sides. And we get y equals negative 3x minus 8 is the equation of the tangent to this equation here when x is negative 1. Okay, let's move on to the next one. That's number 2. Find the coordinates of the points on this here where the tangent is horizontal. Okay? Okay, so what we want to do here then is we know that the tangent is going to end up being horizontal. So if we're looking for the tangent line, the tangent, like we know that the slope of the tangent is horizontal, which means that basically means that the slope is 0, right? So if we know that the slope of the tangent, that always means take the derivative, right? So let's take the derivative of this thing here. So we have 2x to the first. 1 times 3 is plus 3. Subtract 1 from there, and the x's are gone, and the derivative of any constant is 0. So there's our f prime of x. There's our derivative function. Okay. We now know that the tangent has to be horizontal, so we know the slope of this. We know that this has to equal 0. So what we do here is just put 0 equals 2x plus 3, because it's telling us that the slope has to be 0. We're going backwards and trying to find the points. So subtract 3. We're just going to solve for x here. Negative 3 equals 2x divided by 2. And we get that x is negative 1.5. Okay, so that's one part of the coordinate. So our answer is going to be negative 1.5. And then all we have to do now is find the y coordinate. Now remember, whenever you're trying to find the y coordinate, always plug your x value back into the original equation, right? So we're going to do negative 1.5 squared plus 3 times negative 1.5 plus 5. Okay, let's do that on the graphing calculator. Now, it's very important on this one here. A lot of people are going to want to do this. They're going to do negative 1.5 squared. But you know that if you take a negative and you square it, you should get a positive. And this is going to end up giving us a negative because the calculator is going to do 1.5 square it and then multiply it back by negative 1. So make sure that whenever you're squaring or taking into some kind of power, put it in parentheses. So negative 1.5 squared like that. Now that's going to turn that back into our positive like it should be. Plus 3 times negative 1.5 plus 5. And that gives us 2.75. So now we know that this part here is 2.75. And that is the one spot on this equation where the tangent's going to be horizontal. So again, just so you kind of get an idea of what we're up to here, it's basically this function would look, I'm totally spitballing, just roughly it's going to look just about like that. And they're saying the one spot where we're going to get a tangent that has slope of 0 is right here at this point, which is negative 1.5 and 2.75. So that's what they're asking us. Okay. C, same idea. So we know that the tangent has a slope of 9. So again, we hear slope of the tangent line. We know we got to do derivative. So that's going to give us 3x squared minus 3. That's gone. And the derivative of a constant is 0. So this is our derivative function. Right? Now it tells us right here, we know that the tangent has to have a slope of 9. So this over here, our slope, is going to equal 9. So we know that 9 equals 3x squared minus 3. And now we just want to solve this. So let's add 3 to both sides. And we get 12 equals 3x squared divided by 3. And we get x squared is 4. So if we square root this, we know that x has to equal positive 2, or also it could work with negative 2. So make sure that you get both of these, because 2 squared is 4 and also negative 2 squared is 4. So there's actually going to be 2 spots on this graph here where the slope, where the tangent has a slope of 9. Okay, so we've got to find both of those spots. So we know that one of them is 2 and something, and we know the other one is negative 2 and something. So let's find both of those. So for this one here, we're going to plug 2 in. So we get 2 cubed minus 3 times 2 plus 1, right? So 2 cubed is 8. Negative 3 times 2 is negative 6 plus 1 is going to give us 3. So one of those points is 2, 3. And then the other one is we do negative 2 cubed minus 3 times negative 2 plus 1. So negative 2 times negative 2 times negative 2 is negative 8. And negative 3 times negative 2 is plus 6 plus 1. So that's negative 8 and positive 7. So that's negative 1. Okay, so there's the 2 different points where the slope has a the tangent has a slope of 9 on this function. Okay, moving on to number 3. Find the equations of the horizontal tangents to y equals 2x cubed plus 3x squared minus 12x plus 1. Okay, so since it says the equations of the horizontal tangents, we know that the slope of the tangent, since it's horizontal, has to equal 0. Okay, so we need to take the derivative. Okay, so that helps us, that gives us the equation to find the slope at any point that we want. Right, at any coordinate. So, and then we actually already know that the slope is 0. So then this is actually going to help us find the coordinate since we know what the slope is. So anyway, find the derivative. So 3 times 2 is 6x squared. And then this here is 2 times 3 is plus 6x. That's to the first. And then 1 times negative 12 is negative 12. And that's minus 1. That's x's are gone, and then the derivative constant is 0. So here's our y prime. Okay, we know that the horizontal, since it's a horizontal tangent, we know that this slope here has to equal 0. So we get 0 equals 6x squared plus 6x minus 12. Okay, so we're going to have to factor this out. Now, hopefully you notice that all of these have a common factor of 6, which is going to make our life a lot easier when we go to factor this without that factor of 6 in there. So we get 0 equals x squared plus x minus 2. So the factors of 2 that have a difference of 1, the only factors of 2 are 2 and 1, right? And they have a difference of 1, that's 2 and 1. So they have to add up to positive 2, so it's going to have to be positive 2, negative 1. So this means that x has to equal negative 2, because negative 2 plus 2 gives us 0, or it can also equal 1, because 1 minus 1 is 0. 0 times anything will give us 0. So we're going to have 2 different tangent lines where the slope is 0, all right, because this is 2x cubed. So again, if we're roughly looking at this here, a cubic function looks like this, right? So we're going to try to find the equation of this tangent line here that's 0, and also at this tangent line here that's 0. Okay, so we're finding the equations of both of those. Okay, now we know that the x-coordinate for one of those is -2 and the other one is 1. So whenever we're looking for the y-coordinate of the other y-coordinate of the tangent point, y-coordinate of anything, just always plug your x in to the original equation, right? So let's do that over here. This is for -2 here. 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 plus 1. So -2 cubed is -8 times 2 is -16. -2 times -2 is 4 times 3 is plus 12. And then -12 times -2 is plus 24. And then plus 1. Right, so let's see. That's going to give us 21. So the y-coordinate is 21. So let's just pretend that that's this one right here. So if we're looking for this equation of this line here, there's a easy way and there's a hard way. But since we know that it's a horizontal line, we know that the slope is 0. So it's really just going to be whatever our y value is. That's going to be, it's just really this here, y equals 21. That's the equation of that line. And let me show you how that works. If we know that the slope is 0, and we know that the coordinate of that point right here is -2 and 21. If we plug it into y minus y1 equals m times x minus x1, our point slope formula, y minus 21 equals m, which is 0 times x minus -2. We know that 0 times anything over here is going to equal 0. So we have y minus 21 equals 0. So add 21 to both sides. And we get that y equals 21 is the equation of our first tangent line. Okay. We also have to figure out what the equation of the other tangent line is down here, right? So we know that the x-coordinate is at 1, right? So let's plug that in to the original equation to figure out what the y is, and that's just going to be the equation of our tangent. So we have 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 plus 1. So 1 cubed is 1 times 2 is 2. 3 times 1 squared is 3. -12 times 1 is -12 plus 1. So that's going to give us y equals -6. So these are our two tangent lines. Y equals 21 and y equals -6. Okay, so that takes a little bit of work to go through and figure those out, but we can do it. All right, C. Find the equation of the tangents to y equals this here, which are parallel to the tangent at 1, 2. Okay, so we got to find the equation of the tangents that have the same slope as the tangent at 1, 2. Okay, so either way, the equation of the tangent, we know we have to find the slope of the tangent. So either way, we know at some point we're going to have to take the derivative. So let's just do that. So y prime equals, derivative of constant is 0. That's x to the first. 1 times -3 is -3. Subtract 1 and the x's are gone. 2 times 12 is 24. Subtract 1 from that, and that's x to the first. And then 3 times -8 is -24. Right? And then x to the second. So here's the derivative, right? So that'll give us the tangent at any point. The slope of the tangent at any point on this function here. Okay, so now we know that the equations that we're looking to are tangent to the point 1, have the same slope as the tangent at 1, 2. So really what we need to do right now is plug in 1 to this here to figure out what the slope is over here, right? So our slope we know is going to be the same as this one here. So -3 plus 24 times 1 minus 24 times 1 squared. So we get negative 3 plus 24, and that's minus 24. So our slope, we got to find the slopes that have negative 3 as their tangent line. Okay? So find the equations of the tangent. So we know the slope is negative 3. So now what we're going to do is we're going to take this negative 3 and plug it back in for this here and solve to figure out where our tangents are. Okay, so what we want to do is we know that this negative 3 goes here. So we got negative 3 equals negative 3 plus 24x minus 24x squared. And we got to figure out what the x's are going to be. Okay, so we can, the negative 3's, we can just add 3 to both sides to get rid of those. So we get 0 equals 24x minus 24x squared, right? We can divide everything by 24 to get rid of those 24s to make it look a little nicer. So we get 0 equals x minus x squared. Okay. Now we'll want to factor just like we did before. This one's kind of a nicer factor because we can just factor an x out of both of those. So if we x divided by x is 1, and then negative x squared over x is x. So x has to either equal 0 or x has to equal 1. Okay. Now, we already knew that this one for sure was going to happen because look, that's this point right here. So by us doing this and knowing that we got 1 as one of our answers, we know that we're at least somewhat on the right track here because we knew that one of those answers had to be 1 since that's this point here that's going to be parallel to the tangent at that point. So we have to go through, we know that the slope is going to be negative 3, and we're going to find the equation of both the tangents. So we have to find the equation of the tangent at 1, where x equals 1, and also where x equals 0, right? So good news is we already know that the y-coordinate of this thing here has to be 2. So we've already figured that one out. Actually, we didn't figure it out. They gave us that one. Okay, and then we also have to figure out what's the y-coordinate when x equals 0. So if we plug 0 in here, so we've got y equals 1 minus 3 times 0 plus 12 times 0 squared minus 8 times 0 cubed. We know that that's 0, and that's 0. So y has to equal 1. So these are the 2 points on this function here where the tangent is going to be negative 3. Okay. So now all I have to do is just plug these both into the point slope formula to figure out what the actual equation is. So we do y minus y1 equals m times x minus x1 for both of these. So y minus 2 in this case equals, our slope is negative 3 times x minus 1. Y minus 2 equals negative 3x plus 3. Add 2 to both sides. Y equals negative 3x plus 5. That's one equation. And then we can also do the same point slope over here. So we get y minus 1 equals m, which is negative 3 times x minus 0. So we get y minus 1 equals negative 3x. Negative 3 times 0 is 0. Add 1 to both sides, and we get y equals negative 3x plus 1. There's the equation of both the tangent lines that are at this function that are parallel to the tangent at 1 and 2. Okay? Okay. Last one. Number 4. Find a, this value here, if this here has a tangent with slope of 2 at the point where x equals negative 1. Okay. So we know that this is the tangent of the slope of the tangent with a slope of 2. So we know we're going to have to do the derivative at some point. So let's try that out and see what it looks like. F prime of x. 2 times a is 2a. X to the sorry, x to the first, right? And then this is 1 times 6 is 6. And then subtract that 1 there, and those x's are gone. And then the derivative of the constant is 0. So our derivative function is 2 times whatever a is times x plus 6. Okay. Now, this tells us here that we know that the slope has to be 2 for the tangent line. So we know that this over here is going to be 2. So let's plug that in. 2 equals 2 times a times x plus 6. Let's see what we can do with this. Let's see. Let's subtract 6 from both sides, right? We get negative 4 equals 2a to the x. Let's divide by 2. We get negative 2 equals a to the x. Sorry, a times x. Okay. Now, we know we're looking where the point is, where x equals negative 1. So let's plug negative 1 in for this x. So we get negative 2 equals a times negative 1, right? So that really is negative 2 equals negative a. So that means a has to equal positive 2, right? And that's all I think we're trying to figure out, right? Find a. Yeah. Okay. So got that one all figured out. Same idea here as what we did up there. So let's find the derivative. So that x is going to come up top, and that's really going to be x to the negative first here, right? So if we find the derivative, f prime of x, negative 1 times a is negative a, and then subtract 1 from that, and that's x to the negative second, right? Okay, so there's our derivative. We know that the slope has to equal 3, so we know that 3 equals negative a times x to the negative second power. Now we actually know that x is 2, so let's just plug 2 in a little bit earlier than we did last time here, negative 2. So we get 3 equals negative a, and then that 2 to the negative second really is a over 2 squared, right? So that's 3 equals negative a over 4. If we multiply both sides by 4, those are gone, and we get 12 equals negative a. So a then has to equal negative 12. Okay? All right, that's all there is for this assignment here. If you have any questions, please feel free to ask in class.